So let's now talk about loops. So loops are one of the most important concepts in any of the languages like R, Python, even C, C++, or Java. So these are basically used whenever you have to do some iterative task, or you can say any repetitive task. Suppose you have to, let me annotate. So suppose you have to print a square of a number ranging between 1 to 10. Okay. So now you are going to write a program which will square the number of from a value between 1 to 10. Okay. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So you are going to write a code like 1 into 1 or 2 into 2 and so on and so forth. Okay. You get the point. But like you can simply do this like by assigning a is equal to 1 and simply printing a into a, right? Again, a is equal to 2, then printing a into a, and so on. So you can write a simple line of code by simply assigning this particular number to the variable, and you can keep on printing that, right? So it can be done when the number is between 1 to 10. It is a tedious task, but still you can do it. Now, if I suppose I ask you to do this 1 to 100, or maybe 1,000, or maybe 10,000, or 1 lakh. Okay, so this is just a basic example. That tasks are actually going to be more complex, but just for the sake of explaining it in a basic term, so I'm going on with a square of the numbers. Okay, so now suppose from 10 I change this to 100 or 1,000 or 10,000. Okay, so now suppose if you are going to assign each time a variable to that number, and again write a code to print that a into a, so it is going to take a hell lot of time, right? And it will be a very tedious task. Like it will be like it will consume a lot of time, and it is actually a waste, right? So for doing these activities, we generally use loops. Okay, so any task that you are going to repeat, okay, so you can simply use loops for that. Okay, so here what you can do, you can simply create a loop that will say that, okay, till my number, that is I. So you can initialize that with say I start from 1. So you can initialize this with 1, and you can write a loop that will say that, okay, until the number I is not less than 100 or equal to 100 or 1,000 or 10,000, keep doing a into a, or sorry, in this case, I into I. Okay, so using this, actually it will give you a result within micro of seconds. Okay, but if you are going to write this on your own, it is going to take a lot of time than that. Okay, so in these cases, loops comes with very handy. Okay. Also, whenever you are talking about list or vectors or any container object, so if you want to perform any certain task on each of the elements out of this list or a vector or any container object, or you can say you simply want to iterate over that list, you want to go through each of the elements and check something. Suppose you have a vector containing this set of numbers, suppose 5 or 10 numbers, and now you want to check whether each number is even or odd. Okay, so in that case, you can simply iterate over this list. You can check each of the element. You can check you can perform a simple if and else condition on that, and you can check whether the number is even or odd. Okay, so these are some basic examples that you can do, but in real life, the loops are actually more important than we can actually generalize in a basic concept. Okay, so in these cases, your loops actually works very well, and it saves a lot of time. Okay, so let's go ahead and see some examples of what all we can do with loops. So basically in R, there are two types of loops, for and while. Okay, so we'll go ahead with for loops. So the basic syntax of a for is that you write for, then simple number I, and then you give a range of number, okay, in between which you are going to iterate this I. Okay, like suppose I told you example that you want to print a square of each number between 1 to 10. Okay, so we are simply going to write for, and then in brackets you can simply give 1, then colon 10. Okay, so for I in, sorry I missed that, I in this particular sequence. Okay, so this is the basic syntax. So let's see this particular thing. Yeah, so for I in or you can if you have a vector or a list, then you can iterate over that vector or a list also. So you have to simply give a range. Okay, so a range of number in between which your I is going to fall. So in this case, I can say between 1 to 10, or you can say 10 to 100, or in case of a list, then you can simply iterate between the index, like the first index to the last index. Okay, so all these things you can give here, that will define the range of I, and then until that complete range is iterated, or your I has moved from the first value to the last value of that range, you are going to do something. Okay, so for our case, we can simply square the number. Okay, so all these things, or when you want to check even or odd numbers, you can simply do a like a percent is equal to 2 is equal to 0. So I'm going to check that particular condition. Okay, so all these things, it will keep happening till your I reaches from the first value to the last value. Okay, so if suppose there are 10 numbers in between, then your loop is going to go up for 10 number of times. If there are 1,000 values, it is going to go up for 1,000 number of times, and so on and so forth. Okay, so let's see an example over this. Okay, yeah, one more concept that you should know about this, that whenever you are going to give I, like suppose 1 to 10, okay, and let's say this is my range, so my I is going to be between 1 to 10, and now I'm doing something like you have written a code, like let's say multiplying something I into I am printing this particular value. Okay, now what happens, so every time you have to actually increase your value as well. Okay, otherwise what will happen, like you written this loop that for I between 1 to 10, keep doing I into I. Okay, and now you didn't increase the value of I, so what will happen, I will always remain 1. Okay, so it will always remain in this particular range, right? So this will become an infinite loop. Why? Because your I is always at 1, and it is always satisfying this particular condition that your I is between 1 to 10, and then this task is going to be keep going on until infinity, right? So to break this particular loop, we are simply going to increase the value of I, so that I can actually shift to from 1 to 2, then 2 to 3, then 3 to 4, and so on and so forth till 10. So that when I becomes 11, this is not in the range between 1 to 10, right? So this condition will become false, and your for loop will stop. Okay, so to break the loop, to stop the loop from working, you have to actually increase the value of I, so that it doesn't get stuck in an infinity loop, right? So let's go ahead and see an example over this. So what I talked to you just right now, so here I am trying to print the square of a number between 1 to 10. Okay, so if you do not use loop, then what you are going to do, you are going to assign I is equal to 1, then you are going to print, let's say, I into I. Okay, then you are going to change the value to I is equal to 2, and then you are going to print then 2, 3, and so on and so forth. You get the drill, right? But actually this is going to take a lot of time. So what we are going to do, we are using for loop. So I am writing for, then in within brackets I'm giving I in 1 colon 10. So we have already discussed about this colon operator in our when we talked about vectors and lists. So this is nothing but this is going to create a sequence that is from 1 to 10. So 1 2 3 4 5 6 till 10. So now my I is going to start from 1, and then it is going to, this loop is going to end when my I reaches 10 and increases more than 10, right? I becomes 11. Okay, so in that case our loop will break. Okay, so for I in between 1 to 10, it is going to iterate this particular thing that we have written inside. Okay, so let's go ahead and run this. So I'm trying to print I into I, and you can see I am increasing my the value of I by 1. You can go ahead and increase by 2, 3, 4, like however number that you want to skip, you can simply add that number in this particular statement. Okay, so now if I run this, so you can see for I, when I was 1, it printed 1 into 1, then I became 2 and printed 2 into 2, then 3, 3 into 3, 4, 4 into 4, and it went on till 10 into 10. Okay, and when my I became 11, this loop actually broke, because now my I is not in between 1 to 10. Now it has become 11. So this condition has become false. Okay, so now that's why the print is not going on. So this is how you break the loop also. Okay, so this is the basic concept of a for loop. So now that I have told you one more thing, that why do we increase this I value? So in basically R and Python, you do not have to do this manually. Okay, so this was this I explained you just for the concept, like why should you actually increase the value of I. But in R, you do not have to do it manually. So even if I do not provide this particular step in my code, and still if I run this, you can say the output remains same. Okay, so the R intelligence, or in Python as well. So these are some characteristics which make these languages very popular among developers, because these things you do not have to do for yourself by yourself, right? This is automatically detected by R intelligence, and it is automatically going to increase your value by 1 till it reaches from 1 to 10. Okay, so I just wanted to clear this up. So yeah, this is also fine and this is also fine. So you do not have to explicitly write I is equal to I plus 1. It is going to be automatically done. Okay. And now if you want to say by default, the step is going to be 1, right? It is going to increase 1 to 2, 2 to 3, 3 to 4, and so on. So the by step is actually 1 in this case. Now, if you want to change that default value, you can simply use a sequence. So if I'm going to write this particular code, so I'm simply going to give a sequence that we have already discussed about. And in that sequence, we are going to simply pass the by parameter, that is, let's say 2. Now, if I'm going to run this, oh, sorry, the syntax is wrong here. So let me change this. Yeah. Yeah. So now you can use this sequence if you want to change the default step size. You do not want from 1, you want from 2. Then you can simply use the sequence method. And then I have given my starting value, that is 1, and I'm giving my ending value, that is 10, and I am giving the by is equal to 2, right? So now what's happening? It will start with 1, then it will go 2, 3, then 5, then 7, then 9, and then if it's going to 11, but that is not in our sequence, that is not going to be printed. Okay. So basically you do not have to do this by yourself in R. So that was the whole point of explaining all these things, and why I explained this to you, to make you understand that this is actually happening behind the scenes. Okay. So if it doesn't happen, if this is not happening behind the scenes, then your loop will go in an infinite, right? It will become an infinite loop. Fine. So okay, so let's go ahead. So now let's talk how we can extract values from a vector. So you can see I have created a vector and I have created 4 values in that vector. So if you want to iterate over each value, so I'm simply going to give for I in vec, okay, and just print I. So what it is going to do, it is treating a vector like a container object, right, which has multiple items in it. Okay. So if you give like this I in vec, so it is simply going to iterate over each of the members in that particular vector, and it is going to give you back that particular vector. Okay. So each time this loop will run, so basically, you can say that, let's say this is my vector, right? 12, 13, 14, and 15. Okay. So now, whenever if you write I in vec, so what happens when your this loop starts? So first time your I is going to pick up this value. Okay. So your I is basically 12. Then your I is 13. Then your I is 14, and then your I is 15. Okay. So whatever the values there are in a container object, so whenever you write a loop and you go iterate over that particular container, then each values become a this I. Okay. So if I'm going to run this, so let's go ahead and run this. So basically I'm trying to print that I. So go ahead and run this, and you can see exactly what I showed you, that I is taking those values. So that exactly is happening. So in I in vec, so the first value it took is 12. So it printed 12. The second value 13, printed 13, then 14, 15, and so on. Okay. So this is how you can iterate over a vector as well. Fine, let's move ahead. So now I'm going to write a simple code that is to find the sum of all even numbers and odd numbers stored in a list, and print them separately. Okay. So this is a very basic thing, the very basic code. So but just to explain you how you can use a conditional operator in your loops, I'm going to go through this code. Okay. So we have already talked about conditional statements, if and else. So I'm going to use that if and else in our list, loops as well. Okay. So I have created a list of numbers. So I have passed all these numbers in this, and then I have initialized 2 variables with 0. So in this particular variable, so I'm going to store the sum of even number and sum of odd number. Okay. Now I'm simply iterating through from I in numbers. So I'm iterating through each of the values present in this particular list, and then I'm going to use the conditional statement. So I'm first going to check if I percent 2 is equal to 0. That means if I divide that number by 2, is the remainder 0? If the remainder is 0, that means that is the even number. If the remainder is not 0, that means it is an odd number. So if this condition satisfy, I'm simply going to add that, like in the even sum, that is 0, I'm simply going to add that number. Okay. So even sum plus that number. So let me run this for you. So what will happen? So these are my numbers, let's say 16, 55, and 33. So let's talk about only these three. We'll get to that later. Okay. So what is going to happen? Now you have written a for loop. So first I is going to be equal to 16, right? And then this condition is going to be checked. So if you divide it by 2, so obviously the remainder will become 0, right? So if the remainder is 0, that means this is even. So now what is happening? So even sum becomes even sum plus that number I. Okay, so initially even sum was what? 0. And what is my I? 16. So now my even sum became how much? 16. Okay, and now suppose instead of 55, in between there was an 18. So this is just for explanation. So now the next number is again 18. So again this condition will be satisfied. So now my sum will become 16 plus 18. Okay, so this is how my code is progressing. Okay, so yeah, so the first thing that is we are using, we are checking if the number is even. If the number is even, we are simply adding that to a variable here. Okay, so now if I go ahead and run this, you can see simply my yeah, so the even number sum, so my even numbers were 16, 58, 24, 54. Okay, so the sum of all those numbers are simply printed, and the sum of even numbers in the list. And similarly, if this condition is false, then my else statement is going to be invoked, and there you can see I'm adding in the odd sum that is initially initialized by 0. So I'm adding that particular number in this odd sum. Okay, so this is how my even number is getting printed and my odd number is getting printed. So I hope you are able to understand how you can use conditional statements in the loops as well. Fine, let's go ahead. Okay, so now you can also use this for loops in data frames. Okay, so here I'm creating a new data frame. So I've initialized 3 vectors. Okay, and I'm simply passing those vectors with the column names A, B, and C. And this is data frame. So let's see this data frame. So you can see I have created this data frame. So all the column values have been filled up. Okay, now if you want to go through this particular data frame, you can simply go like let me show you for a second. So now if you want to access a certain column in this particular data frame, so what you are going to do, we are going to pass the index, right? If I want to access the second column, so I'm going to pass df2, and it is going to return me the second column. Or if you want the third column, you can simply pass df3. Okay, so basically in this df you have to simply pass the index, right? So what I'm going to do here, I'm simply uh, initializing my I from 1 to the number of columns in df. Okay, so if I go ahead and check the number of columns in df, what is this going to return? This is going to return 3 because I have 3 columns. So basically now my I is initialized from where to where? So now I is initialized from 1 to 3. Okay, so basically 1, 2, and 3. Okay, so now when I is 1, so I'm simply going to print df and then in the subscript 1, right? So this is going to return what? My first column. Then I will become 2. So then I will be printing df, then 2. Then I will become 3. So df 3, right? So this is how I'm going to access each of the elements. So let's go ahead and run this. So let me run this for you. So now you can see each column has been printed separately. Okay, so this is how you can access uh, df elements using for loops as well. Okay, or you can simply actually iterate through the column names as well. So if you remember, I have told you this particular function that is call names. So this simply returns a vector of all the column names, right? So now you can simply iterate because this is also a container object, right? So you can iterate through this also. So what is going to happen? So your I will now take values from A, B, and C. So initially it will be I is equal to A, right? Then I will be equal to B, and so on and so forth. Okay, and I have also told you how can you access elements through a column. So you can simply pass the index as well as you can pass the column names. Okay, also, right? So if I write dfa, so this is going to give me back the first column, then dfb second column, df3 third column. Okay, so I'm simply passing all the column names separately, and if you run this, you can see it is giving you the exact result. Fine. So this is how you can access the values from data frame. Okay, so now this will be one task for you. Go ahead and access the elements of matrices, okay, using for loops. Right, great. So let's move ahead and talk about our nested loops. Right, so what is a nested loop? So we have talked about our nested if and else conditions. So what was happening exactly? So in a if, you were writing another if, then you were writing another if, okay, and then a else. Okay, so this was we called a nested if, right? So similarly, when you write a for, and inside that for you write a for, then again inside a write you are write a for. So basically you are creating a loop inside a loop inside a loop. Okay, so these kind of things are called nested. Okay, so basically we are creating loops inside a loops. Okay, so that is called nested for loops. So let's go ahead and see how this works. So basically First, I'm going to iterate from my I from 1 to 3. So basically, now I'm storing that I has values 1, 2, and 3. So suppose it is a list like this, right? And then I'm also initializing a value j, okay? And in this j, I'm storing value 1 and 2, right? So what I'm exactly doing here, I am looping from 1 to 3, right? 1 to 3 I'm looping, and inside that loop I have created one more loop, and that loop will be looping from 1 to 2. Okay, so what will happen when the first loops will start? Okay, the first loop will say that the value of I is equal to 1. Okay, and now let's forget the first loop. Okay, my first loop has given me value of I, that is 1. Now let's come into the inside loop. Okay, so here my value will start with j is equal to 1, right? And then what I'm doing, I'm printing I into j. So I will print 1 I into j, that is 1 into 1. So it is going to give me back 1. Fine. So my first value was 1. Then my second, in the second loop, the first value was 1. Now what is going to happen, before we go ahead with this loop, all the values in this loop will be exhausted. Okay, that means whatever values you have given in j, that is 1 and 2. So all these value will be used in this loop. Then and then only we are going to go back to the first loop. Okay, so now this will be printed 1. Now again my j will take a value that is 2. Okay, and now the multiplication will become, because I is still 1 but j has become 2, so I into 2, the second number will be printed is 2. Okay, so now we have exhausted all the values that is present in this j. Okay, now my loop will go back in the first loop. Okay, and now we had how much value, 1, 2, and 3. So we have already dealt with 1. So now my I will become 2. Now it will again come back into this loop, and again my j will be starting from 1, because it's a fresh loop, right? So again my j will be starting with 1. So again 1 into 2, that is again we will be getting a 2. Now again, since I have still one value left for j, so now my j will take a value called 2, right? And now my I was 2, my j is 2, so 2 into 2. So the fourth value is going to be 4, right? And this is how, until all the values in both the loops are exhausted, my loop will keep on going. Okay, so basically how many times this will run? This will run 6 times. Okay, 2 for this. First I is equal to 1, then j is equal to 1, j is equal to 2, then I is equal to 2, again j is equal to 1, j is equal to 2, then I is equal to 3, j is equal to 1, j is equal to 2. So basically 6 times your loop is going to run. Okay, so if I go ahead and run this particular code, so we are going to see that exactly the same thing that I told you. When I was 1, then j was 1, so 1 into 1, 1. But still I is 1, j becomes 2. So 2 into 1, 2. Okay. But now the new loop, I becomes 2, j becomes 1. So 2 into 1, 2. Now I remains 2, but j becomes 2. 2 into 2, 4. Okay. And so on. This circle, this loop is going on. Okay. So this is the basic example of nesting your loops. Right, and this is how you can actually also using this nested loops, you can actually access elements inside a matrix. Okay, so I'm not going to execute this code. You, if you want, you can write this code on your own, or if you want to copy it and try to run it and see what exactly is going on. Okay, so I have written three of these lines for getting a rows and columns out of a matrix. Okay, using the nested for loops. Go ahead and try this on your own and let me know if you have any doubt. I will clear that up. Okay, fine. So this was our basics of a for loop. Okay, and this is how you can use the for loop or nested for loops. Okay, now let's go ahead and discuss about another loop, that is while.